Welcome to Internet Quality Academy. The channel is for the quality control engineer, site engineer, and the civil engineer who are working in the construction field. In this channel, we are dealing with anything and everything which is required to get success in the construction. Today also, I'm going to discuss about a very important topic, that is self-compacting concrete. What is self-compacting concrete? What is the characteristics of self-compacting concrete? What is the relevant IS code? What is the brief history? That is how it is developed, and what is the uses of self-compacting concrete, and what is the different types of self-compacting concrete. Today, I will discuss each and everything about self-compacting concrete. So stay tuned until the end to get the full information about this. And if you are new in my channel, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. So without wasting time, let's jump into the subject. And it's my request, do not skip this any part of this video. Watch from start to end to get the full information about self-compacting concrete. First, we need to know what is self-compacting concrete. Self-compacting concrete is highly flowable, non-segregating concrete. So first things that it is highly flowable, non-segregating concrete that fills uniformly and completely every corner of formwork by its own weight and encapsulate reinforcement without any vibration, or maintain homogeneity. That means first things, it is not required any type of vibration. Okay, and it is flowing into its own weight without segregation and bleeding. So my criteria of the concrete, what is the properties that has to be fulfilled: strength, durability, the segregation will not happen, bleeding will not happen, and it will flow every corner of the concrete, and there will be no air pockets because it is not required any compaction or the vibration. So whatever the concrete have, that all stability or all the things, that is called the self-compacting concrete, is highly flowable because it needs to flow by its own weight. Non-segregating concrete that uniformly and completely flow every corner of the formwork. So that is the definition of self-compacting concrete. So it is not required any type of vibration. You need to just pour the concrete and it will flow under its own weight without segregating its part or bleeding of the water. So that is the self-compacting concrete. Now, what is the relevant IS code for that? That is IS 10262 2019 and IS 456. And it is in section 4, clause 7 and 8 in IS 10262. It is mentioned everything in details about the self-compacting concrete and how to test self-compacting concrete. That is IS 1199 part 6. That is also our relevant IS code for that one. So these are the code that we need to know. So before going into what is the characteristics of self-compacting concrete, let's see the what is the history or how it is developed, because we need to know what is the background. The background is, it is start in the 1980s Japan. The concept of SCC originated in Japan in the late 90s due to the growing need to address durability concern in concrete structure. So it is first steps taken by the Japan in 1980. Then Professor Hajime Okamura from the University of Tokyo led the initial research efforts to develop a type of concrete that could flow and compact itself without the need for vibration. So whenever the durability concern is coming, the Japan's start is their research, and they find the concrete which is not required any type of vibration. In 1990s development, by the early 1990s, the development of SCC was well underway, focusing on improving its workability and flow characteristics while maintaining strength and durability. So when it started in 1980, 1990, it is coming in the shape. Then introduction to the market. SCC was introduced to the construction market in Japan in 1990s, initially for applications with complex formwork and densely reinforced structure. Then it is international adaptation. Throughout the 1990s and 2000, SCC gained international recognition and was adopted in various countries for ease replacement and superior finish quality. Then standard and guidelines. In the early 2000, several standard and guidelines were established to ensure the consistent use of SCC. then again it is widespread in the use. So these are the development from 1980 to till now. The research and development is still in the underway, and we will get in the future the more durable and more SCC concrete. So it started in the Japan in 1980s. Now it is throughout the world it is using, that is the self-compacting concrete. Now we need to know what is the properties of the self-compacting concrete. That is the main thing. Then how we can ensure or we can call that this concrete is the self-compacting concrete. The first criteria is the filling ability and flowability. So these are the things all is mentioned in the ISO 10262 in the section 4 in clause 7. So but what is filling ability or the flowability? This is the ability to of fresh concrete to flow into all and fill spaces within the formwork under its own weight. That means the first criteria would, it has to satisfy that it should flow continuously and it should fill all the formwork under its own weight. So these are the first criteria has to satisfy to call it as a self-compacting concrete. So this is the first thing, that flowability we need to measure. So some flow test is the measure for the flowability, and the classification of the basis of some flow. And what is some flow test? That we all know that we need to test the sum flow. Here is a picture, you can see this is a sum flow test, and where is the sum flow test is there, and we have the different three kind of concrete or the self compacting concrete on the basis of sum flow or the flowability. That is SF1, where the sum flow is between 550 to 650 mm, SF2 sum flow in between 660 to 750, and sum flow 760 to 850. That is three type of sum flow is there, and according to that there are three kind of concrete we can say, that is SF1, SF2, SF3. So whenever we are doing design our concrete or the self concrete, we need to understand what kind of flow we need, whether it is a SF1, whether it is SF2 or the SF3, and accordingly the mixed proportion will be changed. And where SF1 can be a slabs, tannin lining, piles. So SF2 walls, column, and SF3 heavily reinforced structure, complex shape of structure. So according to our structure, we need to finalize what type of sum flow I need for my concrete, and according to the sum flow, we need to proportionate or we need to prepare the mixed design, whether it is a SF1, SF2 or the SF3. So the first criteria for the characteristics of the self-compacting concrete, that is flowability and the flowability. And these are the things what are the sum flow test we have discussed. That sum flow test is measured as per ISO 1199.6 and for the self-compacting concrete. Then the next characteristic is the passing ability. What is passing ability? Passing ability describe the capacity of the fresh mix to flow through confined space and narrow openings such as areas of congested rainforest without segregation. Now, in normal concrete, what is happening? We place the concrete and we need the doing the vibration, so it is flow during the effect of the vibration. But in the self-compacting concrete, there is no vibration and there is a congestion of the reinforcement. So reinforcement is there. So how it will flow through the reinforcement without segregating and make it a homogeneous, so that that is called the passing ability. And L box test is the measure of passing ability. So the minimum ratio of the depth of the concrete to the horizontal section to the relevant to the depth of concrete vertical section is considered to be 0.8 to call it's a self-concrete or the passing ability. But what is that? Let's see in the IS 10999 that what is the L box test. That is, it is in the IS 1199 part 6. Let's see what he is saying in this code. See, here is saying this is the L box test, and L box test is the, see, here it is a L type of box. Here is the reinforcement is like this. So we poured the concrete from here and it is flowing through this L box or through in this reinforcement. And what is the ratio? Here it is the ratio of H1, this is the vertical portion, and this is the H2. This is the horizontal portion. So ratio between H1 and H2 that we need to measure according to this, and this is called our segregation ratio. So this has to perform whenever we are doing any kind of self-concreting. These things has the L box text. So this criteria has to satisfy in order to call it the self-concreting concrete. That is the passing ability, that L box test to be measured, and it should be 0.08 the minimum. So this become the passing ability test for the self-compacting concrete. So we discuss flowability, then the passing ability. Now the segregation. So whenever it is flowing under its own weight, it has to be that tendency that the wet particles, that is the heavier particles, that means the coarse aggregate, fine aggregate, could be separated from its mixes like water and cement. So if it is happening, then the concrete will not be homogeneous, and the strain, the durability will be a problem. So whenever we are doing the self-compacting concreting, we need to be very careful that there will be no segregation. If the segregation is happen, then we will not get the right kind of material. So whenever it is flowing, it's under its own weight, the segregation resistance has to measure. So what is that? This is the ability to fresh concrete to remain homogeneous in composition while in the fresh and state. Segregation resistance test is performed to check its porosity, a property of fresh concrete. So these are the tests we need to perform. What is the segregation resistance? But it should not segregate. And segregation resistance shape test is the measure for the segregation resistance. So in the next video, I will make that what is segregation resistance test. But we need to know that what is segregation test. So simply, it is available in the IS 10262. We can check from there itself what is segregation test. Passing abilities or flows and segregation. Yeah. The segregation test is saying after sampling the fresh concrete is allowed to stand for 15 minutes to any separation or bleed water is to be noted. So bleeding is to be noted. The top part of the sample is then poured into a sieve with 4.75 millimeter square apparatus. After 2 minutes, the weight of the material which has passed through the sieve is recorded. The segregation ratio is then calculated as the proportion of the sample passing through the sieve. So these are the simple method we need to follow to making the segregation resistance. And what is the segregation ratio? And according to the segregation ratio also, self-compacting concrete differed. So what according to the segregation ratio, there are two types of type of concrete. That's SR1 and SR2. SR1 is segregation ratio is 15 to 20%, and SR2 is less than to 15%. And flow distance is less than 5 meter. And if in SR2, that flow distance is more than 5 meter. So according to our requirement, when there is a flow distance is 5 meter or the more than 5 meter, we need to choose the SR1 category or the SR2 category. In the filling ability, we have checked that there is a SF1, SF2, and SF3. Now for the segregation resistance, there are SR1 and SR2. So we need to first find out what is my structure and what is my concrete and what is the characteristics. And accordingly, these characteristics, we need to prepare our methods, our mixed design. So these are the segregation resistance. So what we discuss filling ability, passing ability, segregation resistance. Now, another very, very important characteristics for the self-compacting concrete, that is viscosity. Why? Because without the viscosity, we cannot achieve the concrete whatever we require. That is why in this self-compacting concrete, we need to add the viscosity modifying admixture or the VMA. So in order to get the right flow or right consistency. So what is viscosity? Viscosity is the measure of fluid resistance to flow. It describes how thick or thin a fluid is and its ability to deform under shear stress. In simple terms, it is an indicator of how easily a fluid can move. So the high viscosity fluids flow slowly, that is honey, and while low viscosity fluids flow quickly, that is water. So viscosity is the measure or the indicator how easily a fluid can move. But why we need to know about this self-compacting concrete? Because self-compacting concrete also flow according to its own weight. So we need to know what is the viscosity of the self-compacting concrete. Viscosity ensures that SCC has the right balance of flowability, allowing to move easily into place and feel complex formworks and tight space around reinforcement. So this is ensuring that the mix or this concrete will flow in every corner of the concrete. So proper viscosity helps SCC maintain a uniform distribution of aggregates of cement paste, leading to consistent quality throughout the structure. That is very much important. If the viscosity is not proper, what will happen? The mix will not be the whenever it is flowing, then the homogeneous way will not happen. What will happen? Some area the coarse aggregate will be there, some area cement paste will be there. So that is why viscosity throughout the whenever it is passing or the flowing, viscosity should be the remain the same, that there will be no segregation, no bleeding, and then homogeneous paste can form inside the formwork. So poor viscosity helps SCC maintain proper viscosity helps SCC maintain a uniform distribution of aggregates and cement paste, leading to consistent quality throughout the structure. Now here it is that now we need to measure the viscosity, and how we can measure that is a V funnel test as described in IS 1199 part 6. Let's go to the IS part 6. There are two different types of viscosity. So let's check in the IS 1199 part 6. So what is saying viscosity? That is a V funnel test. Where is the V funnel test? Let me check. See, these are the V funnel test. Concrete is poured and it is coming down this area. And now we need to measure how much time it's taking to pass the V funnel, the concrete. And according to that, there are two kind of the concrete or the self-compact concrete is there. So what is that according to the viscosity? So that is there are two kind of, that is a V1 and V2. Then time taken to pass the concrete from V funnel to be less than 8 seconds, and V2 it is in between 8 to 25 seconds. That is our V1 and V2. There are two types of viscosity or viscosity SCC is there. V1 has good filling ability. Even with congested reinforcement, it is capable of self-leveling and generally has the best surface finish. Now, what is V2? V2 class viscosity is more likely to exhibit thixotropic effects, which may be helpful in limiting the formwork pressure or improving segregation resistance. So it helps to minimize the pressure on the formwork and improving the segregation resistance. That means that segregation will not happen. But here is another thing is thixotropic effects. It is also very much important to know what is thixotropic effect, because this is the main things for the self-compacting concrete. So whenever we are doing any viscosity or viscosity modifying admixture, we need to consider that it should be thixotropic effect. So these are the four characteristics. In the next, we'll discuss what is thixotropic effects. But from the characteristics, we can understand there are four characteristics we need to know as per IS 10262. That is the filling ability, passing ability, segregation resistance, and viscosity. According to the filling ability, there are three kind of SCC, that is SF1, SF2, and SF3. And passing ability should be minimum 0.8. And segregation resistance is SR1 and SR2. And viscosity is a V1 and V2. So why I'm saying this? Because you need to, this data has to be find out what is your requirement whenever you are doing any mixed design for the self-compacting concrete. According to that, the next part, how to do the concrete mixed design, that will be changed, the proportion will be changed. So you need to find out what is your structure and what kind of viscosity, what kind of filling ability, what kind of segregation resistance you need. So, but these four characteristics is mentioned in the IS 10262. This is the main characteristics of SCC, and you need to follow whenever we are dealing with the SCC. Now, what we discuss, we have discussed in the viscosity parameter, that is a thixotropic effect. And what is thixotropic effect? The thixotropic effects refer to a property of certain material that exhibit a decrease in viscosity over the time when subject to a shear stress, and then gradually return to a more viscous state when the stress is removed. Essentially, thixotropic materials become less viscous when stirred, shaken, or otherwise agitated, and return to their original thicker consistency once the agitation stops. So in the thixotropic effects, which means whenever it is shear stress or the agitation is there, again, whenever it is removed, again it will come into the original state. So, and it is more flowable and it is a viscous. So that is why we need to add viscosity modifying admixture to for this thixotropic effect, and how it can be effect in our SCC concrete. Then workability, when SCC is an agitator or vibrator during placement, the viscosity decrease, allowing to concrete to flow and fill molds and formwork easily. So this thixotropic effect, while it's happening when it is flowing, it is decrease the viscosity and allowing concrete to flow and fill the molds. And then stability, so it is already full. Now what has happened, when the agitation stop, the viscosity increases, which helps prevent segregation and ensure uniform distribution of aggregates and cement paste. So what is happening for this thixotropic effect, first it is allowing to flow out inside the formwork, and then again it is preventing the segregation and the bleeding. So that is why this thixotropic effect is very much important. And whenever, that is why the VMA or the viscosity modifying agent we are using, admixture we are using in this self-compacting concreting. So these are the properties of the self-compacting concreting, and now we need to know different types of SCC. So let's summarize first. What is segregation, self-compacting concrete? What is relevant IS code? What is the background or history? What is the properties of SCC, that is flowing ability, passing ability, segregation resistance, and the viscosity? And then what is thixotropic effect and how it is improve the concrete or the self-compacting concrete. Now we need to know different types of self-compacting concrete. First is powder type self-compacting concrete. Now, what is powder inside the mix? That powder means whatever the particles finer than 0.125 micron, 0.125 millimeter, that is called the powder content of the mix. So what is the powder type self content? That means powder content will be more. So it is mentioned in the ISO 10262 that below the 0.125 millimeter, the particle is considered to be powder. So what will be that? That will be the cement, and if you are using fly ash, GGBS, that is all coming into the powder. And whatever the percentage passing in the same for the fine aggregate, whatever the percentage is passing through 0.125, that is also considered to be as per the powder content. So in these three together, cement, fly ash, GGBS, microsilica, and the finer particle in the fine aggregate, that is the powder type powder content of the concrete. What is the characteristic of powder type? Use a high content of fine material, cement, fly ash, ground granite, blast furnace slag. It's selected to achieve the desired flow and stability, achieve self-compatibility primarily through the powder content. So these are the powder content concrete, or SSC, SCCP. And the viscosity generally has higher viscosity compared to other types due to increase the fine content, and suitable for use in situation where higher powder content is acceptable or beneficial. So according to your requirement, that you need to find out the whether the powder type self-concreting is viable or not. Then viscosity modifying self-compacting concrete, SCCV. What is that? Use viscosity modifying admixture, VMS, that already I discussed to make for the thixotropic effect, achieves the desired flow properties, allows the lower powders content compared to SCCP. So in SCCV is lower powder content, but we need to use the VMA or the viscosity modifying admixture. Viscosity can be finally controlled using VMS, providing a balance between flowability and stability. Here we are controlling viscosity using the powder content, but here we are controlling the viscosity using the VMA or the viscosity modifying admixture. Application, ideal for application requiring precise control over viscosity and where the powder content needs to be optimized. So where the powder contents also need to be optimized as per IS code, it is saying it should be 400 to 600 kg per cubic meter. But if we are induced that the powder content is more, become 600, 700. So what we need to control the powder content, and that is time we need to increase the viscosity, or we need to modify the viscosity. That time this VMA is using for the flow availability. So first is self-compacting concrete powder types and viscosity type, and then combination type self-compacting, that is SCCC. That means achieve a self-compactability through a combination of high powder content and viscosity modifying admixture. provides a hybrid approach utilizing the benefits of both powder and viscosity modifiers. So here we are only using the maximum powder content, here the viscosity modifying agent, and here we are using BMA as well as the powder content is high value, so that it is a combination type. And where it is used, offers a balanced viscosity that can be adjusted through the mix design. Application suitable for a wide range of applications, offering flexibility in mix design to meet specific project requirement. So why these three type? Because there is a constraint of the powder content, there is a constraint on viscosity content. So when according to the constraint and according to the requirement, according to the environmental condition, we need to modify, and according to that, we need to modify the powder content, viscosity modified content, or the hybrid content. So that is why there are three types of self-compacting concrete, but the powder type, viscosity modified, or the combination. So these are the thing about the self-compacting concrete. That is, let's summarize what is self-compacting concrete, what is the relevant IS code, what is the background or the history, how it is developed, what is the properties of self-compacting concrete, what is the thixotropic effect, and different types of self-compacting concrete, and how to measure as per ISO 1199 and ISO 10262. So I hope you enjoy this one, and if you find this useful, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notifications. And I'm waiting for your valuable comment, so that from your valuable comment, everybody will be benefited. And thank you once again for watching me. And if you want to know anything more about quality control and construction, please let me know. I will come with more content like this. And thanks again.